Hello everyone. So today we are going to simulate a half-wave power rectifier in PLECS software. So we will discuss about the half-wave rectifier with the resistive load. Then we'll discuss about the half-wave rectifier with the inductive load, and then with the freewheeling diode operation. So now let's build the circuit for the half-wave rectifier by importing the components from the library. So we will have to import voltage source, diode, a resistor, then a voltmeter, and we need to connect them. And then finally, after setting the value of the resistive load and then setting the value of the voltage source, we need to connect a scope at the output as well to see the output voltage, right? So let's import the scope and connect it to the voltmeter output. Now let's change the simulation parameters to simulate for only few cycles of the supply. Let's connect an ammeter as well to view the current of the rectifier. So just let's break the circuit and connect an ampere meter like that. So we will connect another scope to the ammeter to view the current. So now let's simulate the circuit. So here is the problem that the scope has not been connected properly. So let's reconnect it like this. So now let's simulate and view the output voltage. So here is the output of the half wave rectifier circuit, and we can see that it is generating a purely half wave output across the resistive load. Now let's see the harmonics of the output voltage. Uh, So before checking the harmonics, let's connect the inductive load and set the value of the inductor such that we can see a significant impact of the inductive load at the output. So after running the simulation, here we go. We don't see any significant impact for this case. We need to increase the inductor value. So let's increase that and simulate it again. So after increasing the value further for the inductance, we see a change in the current and obviously a different output in this case. So some of the negative portion of the supply is also appearing across the output. So now let's connect a freewheeling diode to remove this negative cycle conduction. So after connecting the freewheeling diode, so you can see that the inductive effect has been removed. So here are the harmonics for the output. So if we disconnect the inductive load and again simulate for the harmonics, we can see that we have the DC level harmonic, then fundamental, and then obviously few other harmonics. So if we change the value of inductor and simulate it again, the coefficients of the harmonics or the amplitudes of the harmonics are changing. So if we further increase the inductive load, the output becomes approximately a sinusoidal wave, and in this case we have only a single harmonic. So these are the current harmonics after setting the fundamental frequency equal to 50 hertz. So in this way we can simulate a half-wave diode rectifier in PLECS software using resistive load, inductive load, and with a freewheeling diode. Thank you.